Hello everyone, my name is Chih-Heng. I am from National Chih-Heng University, Taiwan. Today I will show you how to do performance anomaly problem using mininet Wi-Fi. Performance anomaly problem was firstly shown in this paper, Performance Anomaly of 802.11b. This paper was published in IEEE Infocom 2003. Think there is a wireless network. If a node is close to the access point, this node will have higher signal strength, so this node can transmit at a higher speed. If there is a node that is far from the access point, this node will have lower signal strength, so this node can only transmit at a lower speed. But if the network contains a higher speed node and a lower speed node, which one can get a higher speed? If you want to know the answer, let us do the experiment later. But this paper are using 11b. Later we will doing the similar experiment, but we will using 11g. Before I do the experiment, allow me to introduce my website. This is my SDN website. In this website, you can find some useful resources about mininet Wi-Fi, container net, and Open vSwitch, P4 switch, POX, Liu controllers. So almost all the articles were written in English. Okay, allow me to introduce mininet Wi-Fi. This mininet Wi-Fi emulator allow you to create Wi-Fi stations and access points. So this emulator can allow you to many wireless experiments. So before doing the performance anomaly problem, you need mininet Wi-Fi emulators. So you can download the mininet Wi-Fi emulator from GitHub, or you can use my provided virtual machines. You can download my provided virtual machine from these two links, and then the login name and the password for my virtual machine is user. Password is user. If you want to have super user privileges, you can use root and the password for Ubuntu. Okay, now this is my provided virtual machines. So now let's start to do the experiment. Now you can open a terminal. Change to super user first. Type SU. Password is Ubuntu. Ubuntu. Okay, go to the mininet Wi-Fi directory and go to example directories. Now first, copy the wmedian interference.py to another file. The new file is a.py. We use gedit to edit this a.py. In this script, you will create access point, 3 wireless stations. Now we need to create one wired node. So you can use this command to create one wired node, H1, and the IP setting for this wired node is 10.0.0.4. we also need to use net at a link to make H1 connect to access point 1. Okay, that's the simulation script. Now we can start doing the experiment. So you can use Python a.py. So let me check here. Okay, I am missing IP here. Save the file again. Running again. So you can see the graph. Station 1 is close to AP1, and the station 3 is far from AP1. So we can use extern station 1, station 3. Now we can use the command iwdev station 1 while less than 0 link to check some informations. Similarly, we can type the similar command for station 3. This is the wireless interface name for station 3. This is the wireless interface for station 1. Here, you can compare the transmitter speed. Station 1 has higher transmission speed. Station 3 has lower transmission speed because Station 1 has higher signal strength compared to the signal strength in Station 3. So now we open two terminal for H1. Here we will use iperf-s-i once, and -u means we will create a UDP server port 5555. Using this command, we will create an iperf server, and this application will running at the port 5555, and each 1 second you will show the average throughput for every second. Similarly, we will type similar command in another terminal. But in this terminal, we will use 6666 port. So now we will try to send the traffic to H1 from station 1. We will use UDP, and the sending rate is 15 megabits per second, and the sending to port 5555. And we can see here. You can see the average throughput at the stage at the H1. You can see around 13.6 megabits per second. Okay, so now let's send the traffic from station 3. So you compare the result here. Station 1 has higher transmission speed. So in this terminal, we can see that H1 can have higher throughput. For station 3, station 3 is a lower transmission speed node. So at this terminal, it will show the average throughput is lower compared to this. So now we want to transmit the data at the same time. Which one can get higher speed? Guess before we run in the experiment. Okay, so you can compare the result here. It's quite similar. Sometimes H1 this terminal can get a higher speed, and sometimes this terminal can get higher speed. But averagely, they can achieve similar results. Why? This is called performance anomaly problems. We need to know 802.11 are using CSMACE CA protocol, carrier sense, multiple access, / collision avoidance. With these protocols, this protocol makes sure that averagely each node can have the same priority to access the wireless link. So, for example, station 1 can access around we can say 1,000 times access the wireless channel. Then station 3 will have similar 1,000 times to access the wireless channels. So assume that the packet size is the same. So station 1, when station 1 access the wireless channel, because station 1 is a higher speed, so the occupation time for the wireless link is shorter. Because station 3 is a lower rate node, it will occupy the wireless channel with much more time. But the access times are quite similar. So the results are quite similar. So this is called performance anomaly problem. What we will get from this experiment. In this experiment, it will teach us when you are using wireless network, you need to know if you are very close to the access point, you can make the access point. Sorry, allow me to explain it again. When you are using wireless network, when you are very close to the access point, you can transmit at a higher speed. But remember, if someone connected to the same wireless network, but he is far away from this access point, it has lower signal strength. It can transmit lower speed. It will also make your throughput lower. So I suggest if you are using wireless network, if you have fully control of the access point, you can make the access point, the transmission rate at a higher speed. Don't set it to auto. In the auto mode, it allows the lower speed node join this network. But if you fix the transmission speed at the access point, only stronger strength node can connect to this wireless network. So that's what we get from these labs. I hope you can enjoy today's experiment. If you have anything to or any questions, you can send me an email. I will leave my email at at the YouTube link. That's for today's experiment. Thank you.